Welcome to the DIY Honda Garage channel. This presentation focuses on the DTCs P0961, P0962, and P0963, which relate to the AT, automatic transmission, clutch pressure control solenoid valve A, errors in the 2016 to 2022 Honda Pilot. These error codes indicate specific issues with how the pressure control solenoid operates, which can significantly affect the smooth operation of the transmission system. The solenoid valves are critical components that manage the hydraulic pressure for clutch engagement, ensuring proper shifting and overall transmission functionality. Notably, these errors are linked to electrical circuit problems rather than mechanical faults within the transmission itself. Understanding the nuances of these error codes is vital for appropriate diagnosis and repair. In the upcoming slides, we will delve into detailed descriptions, possible causes, symptoms, and systematic troubleshooting steps. The AT clutch pressure control solenoid valve A plays a pivotal role in the functionality of the automatic transmission by regulating hydraulic pressure applied to the clutch. This component is located within the transmission assembly. It is responsible for engaging and disengaging the clutch based on input from the Transmission Control Module, TCM, thereby facilitating smooth gear transitions. The error codes P0961, P0962, and P0963 indicate performance issues, low input, and high input scenarios, respectively. If the solenoid fails to perform as intended, it could result in rough shifting, delayed response, or even transmission slippage. During diagnostics, it's crucial to confirm that the issue is rooted in the electrical circuitry and is not a mechanical failure within the transmission. By understanding the component's location and role, technicians can better isolate the source of the problem. The potential causes for error codes P0961, P0962, and P0963 typically revolve around electrical issues in the circuit connected to the AT clutch pressure control solenoid, valve A. An open wire in the circuit can result in a lack of signal to the TCM, thus triggering a performance error or abnormal voltage input signals. Similarly, a short circuit to ground can cause incorrect voltage readings that lead to low or high input errors. Additionally, corroded connections can compromise the integrity of the electrical circuit, affecting communication between the solenoid and the TCM. Each of these issues underscores the importance of a thorough visual inspection, as well as electrical testing, prior to attempting component replacements. Ensuring a secure and clean electrical connection is crucial for maintaining proper functionality of the solenoid and overall system performance. Users may experience several symptoms related to the DTCs P0961, P0962, and P0963. One of the most noticeable symptoms is rough shifting. This occurs when the automatic transmission has difficulty smoothly transitioning between gears. Additionally, drivers may notice a delayed response during gear shifts, which can lead to an unsettling driving experience, particularly during acceleration or deceleration. Another alarming symptom could be an increase in transmission slip, where the engine revs higher without a corresponding increase in vehicle speed. This slip not only affects performance, but can also lead to further mechanical issues if not addressed promptly. Recognizing these symptoms early on allows for quicker troubleshooting and minimizes potential damage to the transmission system. Awareness of these indicators is crucial for vehicle owners and technicians alike. The first step in troubleshooting DTCs P0961, P0962, and P0963 is to verify the issue through a series of preliminary checks. Start by turning the vehicle ignition to the on mode, ensuring all electrical components are powered. Next, use the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. This process resets the system and allows for fresh readings. After clearing the codes, turn the ignition off and then back to the on mode again. Take a moment to wait for several seconds to enable the systems to initialize before checking for any pending or confirmed DTCs once more using the HDS. If the same error code returns, this indicates that the failure persists, warranting a deeper investigation. However, if no codes appear, it could suggest an intermittent issue that might need closer attention to wiring and connections. Step 2 in troubleshooting involves checking for an open wire in the circuit. Begin by ensuring the vehicle is in the off/lock mode to safely work on the electrical system. Disconnect the TCM subharness 26P connector along with the TCM 58P connector to isolate the circuit. With these connectors detached, the next step is to measure continuity between specified test points. The first test point involves using the TCM subharness connector number 3 while checking continuity to the TCM 58P connector number 54. Repeat this continuity test using TCM subharness number 4 and TCM 58P number 6. If continuity is confirmed on both tests, this indicates that the LSA and VBSOL2 wires are not open, allowing you to proceed to the next troubleshooting step. If there is no continuity, then an open circuit exists that requires repair. In the final troubleshooting step, the focus shifts to ensuring that there are no shorted wires in the LSA and VBSOL2 lines. Continuing with the previous setup, check for continuity between specific test points from the TCM 58P connector to the vehicle's body ground. This step is crucial to confirm that there are no unintentional connections causing erroneous signals. If continuity to ground is present, then a short circuit exists, necessitating repairs to the LSA and/or VBSOL2 wire. Conversely, if no continuity is detected, it indicates that the wires are intact, and the focus should shift to replacing the hydraulic control unit. This step is vital for restoring functionality and ensuring that the automatic transmission operates smoothly. A systematic approach in these checks allows for targeted repairs, thus enhancing the efficiency and reliability of the vehicle. After completing necessary repairs related to DTCs P0961, P0962, and P0963, it's crucial to validate the repair effectiveness thoroughly. Start by rechecking the DTCs using the HDS to confirm that no trouble codes have returned. Once confirmed, conduct a test drive under varied driving conditions to observe the vehicle's performance. Pay close attention to how the transmission shifts. Ensure it engages and disengages smoothly without any roughness or delays. This on-road verification is essential to ensure that everything is functioning at optimal levels, as it represents real-world conditions. Finally, document the repair process and the results of your tests to maintain accurate service records. This final verification ensures customer confidence and satisfaction while upholding the vehicle's integrity and reliability. Preventive maintenance plays a crucial role in safeguarding the integrity of the automatic transmission system and avoiding future occurrences of DTCs such as P0961, P0962, and P0963. Regular inspections of the wiring associated with the AT clutch pressure control solenoid, valve A, can help in identifying potential issues before they escalate. It's also essential to maintain clean connectors, as corrosion or dirt can effectively disrupt electrical signals and lead to performance failures. Additionally, monitoring and checking transmission fluid levels regularly is vital. Proper fluid levels ensure that the hydraulic systems within the transmission operate smoothly and effectively. By implementing these preventive measures, vehicle owners can substantially reduce the risk of encountering similar diagnostic trouble codes in the future, enhancing both safety and performance. In conclusion, addressing DTCs P0961, P0962, and P0963 requires a thorough understanding of the AT clutch pressure control solenoid valve roles and functions. The significance of diagnosing electrical issues accurately cannot be overstated, as these codes are directly tied to the performance of the transmission system. Recognizing symptoms early, performing systematic troubleshooting, and implementing repairs effectively can restore proper operation and reliability. Furthermore, consistent preventive maintenance ensures longevity and performance, mitigating the risk of these DTCs reoccurring. To maintain a high level of vehicle performance, it is vital for vehicle owners and technicians alike to prioritize these troubleshooting and preventative measures. By doing so, the overall reliability of the Honda Pilot can be significantly enhanced, ensuring a smoother and safer driving experience. Please like and subscribe to the channel. See you next time!